Today, if you were to take a trip in almost any direction across our great country, you might suddenly come upon a sign such as this: Atomic City. This means the location nearby of one of our atomic energy plants, a potent reminder that we now live in the atomic age. What are such communities like? Atomic cities, cities near atomic plants, are pleasant places of comfortable and well-built family homes. There are modern schools and churches, libraries, hospitals, post offices, and railroad depots. A few are government-owned, most are not. There are bustling business sections. With the ever-increasing use of nuclear energy, more towns may eventually become atomic cities, cities near safe and efficient atomic plants. Yes, our atomic city is exactly like any other, and special and detailed precautions are taken to keep these expanding communities that way. This golf course, for example, similar to thousands just like it all over the country, with well-tended greens and tricky traps. But if this player should send a long drive out of bounds, she might discover this man. He is protecting the people who live near an atomic installation by taking vegetation samples to test for the presence of radioactive materials. For example, thousands of samples are taken yearly in the region of Richland, Washington, where AEC's Hanford Works is located. Also tested are the water, the air, and the soil. Hundreds of thousands of samples are collected and analyzed yearly. There are many steps in this analysis, but one of the most important is counting for radioactivity in a device such as this. All year long, in the region of this and other atomic cities, crews range the countryside, taking earth, vegetation, and water samples. Should above standard amounts of radioactive substances be detected in an area, the atomic energy plant would take steps to control the amount of gases or smoke which might settle on the countryside. This would quickly reduce the levels of radioactivity. Here at Hanford are stored some 15,000 soil samples, classified as to type, depth, and time. Such surveys are typical of the lengths to which these scientists go in order to make certain that no occupant of any such city need ever fear the proximity of an atomic energy plant in which he or one of his neighbors might work. These samples are of great variety. They range from sand, loam, clay, gravel, and many others. Some types of soil retain radioactive materials longer than others. All contain some naturally occurring radioactive elements. Whatever their nature, the amount of radioactivity present will be determined at the laboratory here at Hanford. This will be done in several ways, including chemical tests. Such work as this goes on year after year with ever-increasing degrees of efficiency as we expand our atomic energy peacetime program. Everywhere in the vicinity of an atomic plant, the amount of radioactivity in the environs will be well sampled. At Hanford, a careful record is kept on a map. Ever stop to think that the breeze which rustles the flowers and trees and carries the scent of spring, the warmth of summer, and the spice of winter could be radioactive? To make certain that the air of cities near atomic installations is always safe, radiation detection shacks are installed. For instance, 16 of these are at Brookhaven. On the roof are Geiger counters and ionization chambers, which actuate the equipment inside the building. This instrument registers radiation. Here is a continuous flow dust monitor. This register panel records the data fed it by the automatic instruments. Such equipment makes it necessary to visit this shack only once weekly to collect the information. This camera takes a picture every 6 minutes and so produces a continuous record. But suppose you are a worker in an atomic energy plant located near one of these atomic cities. This is you coming home to your family. Aside from the usual safety precautions, what steps are taken to protect you at work? Matter of fact, there are many. So many that working in these plants is among the safest occupations in the world. Let's take a look at just one. This man is a lathe operator working on uranium. A hygiene engineer is about to take a sample of the dust in his vicinity. The instrument he is using is called a cascade impactor. An amazing thing about this device is the fact that it separates dust by particle size. A glass slide in the instrument has an adhesive surface to which the dust sticks. Such samples are taken at regular intervals in all places where there is any chance that the dust in the air may be radioactive. Now comes the analysis of the dust. This is the first step in an elaborate survey which will determine the amount of radiation in the sample. The technician removes the glass slide with the dust clinging to the adhesive and places it in a radiation counter. By reading the dials on this machine, the engineer can accurately gauge the amount of radiation in the dust being breathed in by the machine operator. Should an excessive amount of radiation register, steps to control it would be taken immediately. Samples go also to the laboratory, where they will be subjected to chemical analysis, as you see being done here. This test will determine the amount of uranium in the sample. This is but one of the many precautions taken by the Atomic Energy Commission to protect the workers at their jobs. But there is another problem facing the people of our atomic cities. A problem which is calling for the best efforts of our scientists. That is the matter of waste disposal. One of the foremost considerations of the Atomic Energy Commission is the safety of these people who work and live in cities near atomic plants. Therefore, waste material which might be potentially dangerous must be removed and stored safely. This work is vitally important. So let's see how the problem is handled at Knowles Atomic Laboratory at Schenectady in New York. You are looking at part of the control panel of the waste disposal plant. As one prominent scientist has said, the speed with which we are progressing in the development of atomic energy may depend largely upon the techniques we devise to dispose of atomic waste products. Here at Knowles, two phases of the problem are being handled. First, disposal of its own radioactive waste. Second, the study of waste problems for other AEC laboratories. This unit is one of the most complete and systematic plants of its kind in the country, capable of handling more than 2.5 million gallons of waste per year. The process is as follows. Radioactive wastes from all parts of the laboratory are collected in these stainless steel tanks. After one of them is full, a sample from it is analyzed and the contents are evaporated. The water comes off as a vapor, which is collected in other tanks. Another analysis follows. If the radioactivity is sufficiently low, the material is discharged. If not, it is treated again. This man is monitoring the cell door through which some waste material is about to emerge. By this time, the residue from the steel settling tanks has been pumped into vacuum dryer cells. In this condition, the material can be removed and disposed of. The drum dryer cell has concrete shielded walls and a lead and steel access door. The waste in casks will be removed by means of a small, remotely controlled railroad cart. The heavy door slowly opens, and the area is carefully monitored for safety purposes. Should there be too much radiation for safety, the door would be closed immediately. The heavy metal door is locked in place hydraulically. And now the cart containing the shielded casks with their burden of radioactive waste can be brought out on the floor. The contents of these two casks are the small residue from thousands of gallons of once highly radioactive waste. Now it has been concentrated to a point where the problem of disposal becomes much easier. It will be hoisted on this overhead crane to the balcony, put on a hand truck, and then taken away for storage or burial. It is a fact that the tempo of work and research in the atomic energy field in the future may be geared somewhat to the speed with which laboratories and installations are able to develop safe and sure processes to rid themselves of the potentially dangerous waste materials created by the very nature of the work. The problem is an international one, as atomic energy work spreads to other nations. Peacetime atomic energy has already brought the world great benefits in the field of medicine, agriculture, biology, industry, and many others. And it will bring more. It will protect your health, improve your food, bring you less costly living products, and a greater measure of leisure and security. It will do this partially through the development of power, tremendous power released by the tiny invisible atom. This will be especially important in the power-starved areas in the world where routine fuels are scarce and expensive. And now the waste material is on its way to final disposal. Yes, on your travels across the continent, you may pass through several atomic cities. Some are large, some are small. But they are all good cities to live in which to raise your family, make friends, and enjoy a full life. Atomic cities, cities near atomic laboratories, will become more numerous as nuclear energy work expands, as we continue to travel into the atomic age. So continue your journey across the country. Who knows? Possibly your own community may one day become an atomic city through the magic of the atom.